The first part we're going to see in this demonstration are the PCS port calls directly from the BPF PCS platform. We will use this data as input to illustrate the use of the DataPorts platform. As a first step, we will create and execute an agent to make the data available for the rest of the platform. Here we see how the port calls are exported. We use this step to show the URL that will be needed for the next step. The data access component has a visual interface that can be used to manage the agents. To create an agent, we have a series of templates to guide the user. In this case, we'll create a publish subscribe agent. We'll use the port call class from the DataPorts data model. We will be asked for some extra information and details. With all this done, we download the template in zip format. Here we have the contents of the zip file, with some instructions on how to build the Docker image that will be needed. Now we have this image created, as can be seen in the agent's dashboard. From there, we can run the agent from this image. We can also modify the interval at which the agent will be launched. After creation, we can see the agent is already running, sending data to Orion every 30 seconds. We'll need to create a subscription to Orion to see the notifications when new data arrives. As support, we'll use Webhook to visualize Orion's notifications. We can create a subscription from the UI itself. We now create the subscription. Every time the agent is executed, we'll see the info in the Webhook website. We can inspect the subscription through the Web UI. After a few seconds, information starts to arrive to Webhook every 30 seconds. In the log section of the Web UI, we can see how the agent has been successfully executed. We are now simulating an on-demand agent execution, which translates historical dataset and makes it available for the upper layers. This is an agent that will return almost real-time data on the user demand. Since the on-demand agents offer an API that other components will call to get homogenized data, here we have a generic example of a call to that endpoint. We'll be running the port call agent for December 2022. The agent is started, as can be seen in the Web UI, both in the Instances and Notifications tabs. In a few seconds, we see the agent has imported the items and finished execution. If we go directly to the Cygnus database, we can see we now have a new collection, port call, with all the imported items. For the data abstraction and virtualization component, we are inside the Cygnus MongoDB, which is the database where the incoming datasets are temporarily stored. We can analyze the data from here if we want to. We make a POST request to the port call agent, a software tool that is responsible for loading this specific dataset to the Cygnus database and then trigger DAV. Pre-processing and filtering software has been indeed initiated by the notification sent from the agent. Pre-processing and filtering runs as a PySpark job in the common DataPorts Platform machines, Apache Spark cluster. As you can see, it only takes a few seconds to complete the processing, filtering and cleaning of the dataset. It has been stored in our virtual data repository as well. After reloading our virtual data repository, we can see that the dataset has indeed been stored there by the pre-processing and filtering software. Also, By checking the newly stored dataset, we can confirm that it has been properly formatted and cleaned based on the agreed upon user's needs. To create a new dataset's metadata in data governance, we first log into the web UI and go to Add Dataset. We fill the form with the necessary data and we submit the petition. For this demonstration, we'll use a port call agent. Now we can log in as a normal user and file a petition for the new dataset. After this, the BPF admin has free rein to accept or reject this petition. Here we see how to make the petition to the selected admin. Once this is done, the admin logs in using their credentials and finds the new petition made by the user a moment ago. The admin accepts the petition. We now continue by accessing the automatic model training engine URL, which redirects us to Keycloak for login. We can see on the right the request, response, and the token that Keycloak returns. After the login, the system lists the available services for the user. To create a new cognitive service, the user selects the type of service and a dataset from the list of datasets available for the provided user by data governance. The selected dataset with filtering rules defined by the user is requested to data abstraction and virtualization via the Kraken-D API gateway and is then used to train the new service. Also, a subscription to semantic interoperability is created to obtain the new data that will be processed by the service. Once the service has been properly trained, we can see and analyze the new incoming data. Once the service has been properly trained, we can see and analyze the new incoming data. The service is now deployed, and as vessels may arrive in undetermined slots of time, a new estimated time is simulated. Therefore, a request was sent to the semantic interoperability endpoint with realistic information, simulating a vessel called Valencia Pilot. When the request is sent, automatic model training engine receives it, calculates the predicted time difference and shows it in the web UI. This ends the demo.